Ow, that hurt.
That's because those brownies are too hot.
Who are you?
It's Kim, and I'm here to do some calc.
Newton's law of cooling states that the rate of change of temperature is proportional to the difference between the object's temperature and the ambient temperature. Newton's law of cooling. In order to find the general solution, we have to separate the variables and integrate both sides. T sub A equals dt equals on the left side, use U substitution. Once we integrate both sides, we get ln absolute value t minus t sub a equals negative kt plus c. We only have to put c on one side because it is a constant. Now, with the natural log, to cancel that out, we will slip in an e to the power to both sides. The left side becomes absolute value t minus t sub a, and the right side becomes c times e to the negative kt. E negative kt multiplied by e to the c. Now e to the c is just c, so this will result in that. And then finally we need to add t to the a to both sides, so this will give us, negative kt, kt, and then t to the sub a and add it to both sides. And now that we have the general solution, we're going to see if Sam can figure the rest out.
Now, with our general solution, t is equal to ce to the negative kt plus t sub a, we can find our particular solution because we know that the ambient temperature is 67 degrees. At 0 minutes, the brownies are at 190 degrees, and at 5 minutes, they are at 170 degrees. To find the particular solution, what we do is we plug in 0 for t, which gives us 190 equals ce to the negative k times 0 plus 67 degrees. This simplifies down to 190 is equal to c plus 67. Because c is a constant, this means that c is equal to 123. Now we have our particular solution, which is t is equal to 123 times e to the negative kt plus 67. Now we can use some of the information we gathered to find k. After 5 minutes, the brownies were at 170 degrees. If we plug this in, what we get is that 170 is equal to 123 times e to the negative 5k plus 67. Subtract 67 from both sides, and we end up with 103 is equal to 123 e to the negative 5k. Divide both sides by 123, and we end up with 0.8374 is equal to negative 5k.
Alright.
Kim, I can't solve it from here. I just don't know what to do.
Ah, an e to the power. Well, to get that, while no one's looking, we're gonna slip in an ln to both sides. This will cancel out the ln of e and just leave us with negative 5k, the exponent. From here, I can divide by negative 5, leaving off with this number. You try it now.
With our k value of 0.03545, we can predict when the brownies will be at the perfect eating temperature of 140 degrees. Our new equation is T is equal to 123, E is equal to negative 0.03545 T plus 67 degrees. If we place 140 in for T, so we get 140 is equal to 123 E to the negative 0.03545 T plus 67. Now, we can just subtract 67 from both sides. This gives us 73 is equal to 123 e to the negative 0.03545 t. Then we can divide both sides by 123. This gives us 0.5935 is equal to e to the negative 0.03545 t. If we take the natural log of both sides, we will get negative 0.5217 is equal to negative 0.03545 t. Now, all that's left is to solve for t.
I don't know the order.
When we solve for t, it shows us that it will take 14.7 minutes for the brownies to cool down to our perfect eating temperature of 140 degrees.
Great job, Sam. Wow.
Alright. Thanks for the help, Kim. I'm never gonna burn myself on a batch of brownies again.
Hey, no problem. That's what Calc is all about. Hey, what do brownies and a baseball team have in common?
I don't know.
They both depend on a good batter.